Okay, for this one, we looked at putting it in the quadratic formula and decided it was easier to complete the square. So here we go, z squared plus 6z. Completing the square, half of 6 is 3, 3 3s are 9. I can't randomly just add 9 to that side. I'm going to take this 20 to the other, but negative 20. I'm going to randomly add 9 to both sides. So because I've completed the square, I've randomly added 9 to both sides so that this will factorise nicely, and that I just took to the other side. Okay? Hope so. So this factorises to z plus 3 squared, because z plus 3, z plus 3, z squared plus 3z plus 3z plus 9, all works nicely, equals negative 11, she says, hopefully. That looks right. Okay, so now z plus 3 equals plus or minus the square root of negative 11, otherwise known as 11i squared, because I squared equals negative 1. So I've called negative 11 11i squared because negative 11 is positive 11 times negative 1, and negative 1 is I squared. Okay, so now I've got z equals, take the plus 3 to the other side, making it minus 3, plus or minus the square root of 11i. The I can come outside, it's a times sign at this point, of the third sign, because the square root of I squared is I. Okay, now let's have a look. There we go. That is the answer, and it must be simplified. Okay, now it was easier to simplify it doing it this way than it was actually doing the quadratic formula. How do you check it on your calculator? Menu and equations, and it's a polynomial, and it's degree 2, and it's 1z squared plus 6z plus 20. Execute, no real roots. Okay, that's fine. Shift setup, and we need to have complex mode, can be that. Execute. So there we go. Now 3.3166, I could go here, and 3.3166 squared. Okay, I could guess 11, couldn't I? I could have actually have guessed that on my calculator, because if I go the square root of 11 and try and remember that, 3.3166 2479, and then go back to my equation in complex mode, simultaneous degree 2, excuse me, so then, oh, whoops, what did I do wrong? I didn't want it simultaneous, I wanted polynomial, degree 2, execute, and so 3.3166 2479, sweet. So that's one of the roots, and the other one, of course, is the minus of the same thing. So if you really don't like doing this, so long as you actually get the answer on your calculator, but then get it in third form by squaring it, and writing the square root of it, yeah, you could get there. Not maybe, I mean, how hard is that? You can do that, it's alright. Okay, next one. P and Q are complex numbers. Now, what does this line on top of the Q mean? That means 2 plus 3i. You just change the sign in the middle, it's the conjugate. Find that, so P and the times the conjugate of Q is 3 plus 4i times 2 plus 3i. And now I expand that, so 2 3s are 6, plus 3 3s are 9i, plus 2 4s are 8i, plus 3 4s are 12i squared, which equals 6 plus 17i, because 9 and 8 is 17, and minus 12, because I squared is negative 1. So that's minus 6 plus 17i. Now I make mistakes all the time, so I like my calculator. And if I go here, option, complex. Let me see. I have got 3 plus 4i times 2 plus 3i, close bracket, execute, negative 6 plus 17i. Sweet. And there we go. Simplified solution. Okay. Nice. Nice. Keep going. Maybe. Solve the following equation for x in terms of p. I want to make p the subject of that formula. No, I want to make x the subject of the formula. Okay, I'm going to square both sides, and then I get square root of x minus 3 times the square root of x minus 3 equals, x minus p, right? So if I square the square root of something, I'm back to normal, right? So here, square root of x times square root of x is x, and then I've got minus 3 times the square root of x minus 3 times the square root of x plus 9 equals x minus p. Okay, x minus 6 times the square root of x plus 9 equals x minus p. Now, I've got x on both sides, it can just cancel, can't it? So I have got, I'm going to switch them over. Oh no, I'm not. That's alright. I'm going to have negative 6 times the square root of x equals negative p. Negative 6 square root of x equals negative p minus 9. And so the square root of x equals negative p minus 9 over negative 6. Okay, and so isn't that the same as p plus 9 upon 6? Because I can take that's negative p minus 9 over negative 6. And yeah, if I times both top and bottom by negative 1, I'm not changing anything. So that equals the square root of x. Now if I'm going to square that, okay, so I've got p plus 9 squared upon 4. Do I have to expand that out? P squared plus 18p plus 9 9s are 81, all over 4 4s are 16. Now, I've found x in terms of p. Sweet, let's see if I'm right. Yes, now that's an or. It's not an and, it's an or. It means that you can stop there and you've got full credit, that's fine. So, yeah, I think all of that was quite fine. And what's the correct expression with the x is eliminated on the third line, or equivalent? Okay, so correct expressions with x is eliminated on the third line. So this bit here was actually achieved. So getting rid of these x's was important for achieved, and if you got to there, you got error. Okay, nice. It's a long enough video.